Most days, we look up and accept a vast blue canopy as a fact of nature, but occasionally the entire atmospheric system breaks. The familiar blue vanishes, replaced by a thick, apocalyptic red haze. Massive wildfire seasons now rewrite the visual rules of our environment. They pump thousands of tons of soot into the air, shrinking the midday sun to a pale white dot behind a dark orange veil. Historically, massive volcanic eruptions like Krakatoa injected so much material into the stratosphere that the discoloration lasted for months. These events triggered widespread panic and directly inspired the screen passing through nature depicted in Edvard Munch's blood-colored skies. This visual shift is so jarring that science fiction writers use it as an immediate shorthand for the alien. A permanently crimson sky tells the audience they are no longer on a world that follows Earth's rules. To understand how a red sky is actually constructed, whether in fiction or reality, we must look at the specific variables that govern the behavior of light. The standard equation begins with sunlight, a white mixture of every color. It remains a focused beam until it strikes our atmosphere. Here, Rayleigh scattering takes over. Short, choppy blue waves crash into tiny gas molecules, scattering in every direction and filling the sky. The first way to alter this blue baseline is to change the distance the light must travel through the air. At sunset, the sun's position forces light to punch through a much thicker horizontal slice of the atmosphere. The blue waves are scattered away long before they reach you, leaving only the longer, lazier red and yellow waves to pass through. Volcanoes amplify this effect by injecting sulfate aerosols high into the stratosphere. These particles act as a global mirror, intercepting light that would normally pass into space. This data from Mauna Loa shows the impact clearly. After the 1982 and 1991 eruptions, direct solar radiation plummeted, while diffuse, scattered light spiked. The sky didn't just look redder, the entire composition of the light reaching the ground changed for years. While volcanic eruptions provide a temporary shift, achieving a permanent red sky requires changing the physical particles the light interacts with. A second path to a red sky involves replacing Earth's tiny gas molecules with a constant suspension of larger, heavier particles. Mars is the primary real-world example. Its thin atmosphere is perpetually saturated with fine iron oxide dust swept up from the surface. Because Martian dust particles are large, they ignore short blue waves and scatter longer red wavelengths, keeping the daytime sky rusty orange. At dusk, this inverts. Red light scatters away completely, leaving a concentrated blue beam to reach the surface, creating signature blue sunsets. If the atmosphere remains Earth-like, the final variable that can be changed is the light source itself. A planet orbiting a red dwarf star receives light that is already devoid of blue wavelengths. Without blue waves to scatter, the sky naturally glows a deep crimson from dawn until dusk. Every sky in the universe is a result of this specific balance between the type of star, the thickness of the air, and the size of its particles. Back on Earth, this specific spectrum of light serves as a critical evolutionary trigger. Experiments show that mammalian body clocks are specifically tuned to shifts in color. Our circadian rhythms rely on the blue light of twilight to determine the time of day, regulating everything from body temperature to sleep cycles. This connection makes modern proposals for climate engineering highly unpredictable. Intentionally spraying aerosols to reflect sunlight could cool the planet, but it would also permanently whiten or redden our daily skies. Altering this filter risks more than just health. Historically, when volcanic ash whitened the skies, the loss of direct vitamin D-producing sunlight triggered widespread seasonal affective disorder and deep cultural ennui, fueling the environmental anxieties that still haunt our art and literature. A sky's color is the visible fingerprint of a planet's delicate life support system. To look up at a blue sky is to see the exact life-sustaining physics required